Good morning, everyone. Welcome to the second day of our Congress. It is our pleasure to welcome all of you here again. And I hope you have been enjoying the debate and networking opportunities here. Today, we will start the day with another keynote speech. Normally, our schedule was planned for hosting Mrs. Manuela Gatto from the Hadid Architect, but she couldn't be able to attend due to her busy schedule. But on behalf of the Congress Committee, I'd like to share our thanks for her efforts to attend. Today, Mr. Jose Pareja Gomez from Zaha Hadid Architects will be with us. Before his speech, I would like to share his short bio with you. Mr. Jose Pareja Gomez, born in Mexico City, he had his master's degree in architecture and urbanism by the Architectural Association in London, UK. He has been a lecturer on diverse technology and architectural forums in Latin America and Europe. He is an associate at Zaha Hadid Architects, where he has worked on a series of urban and architectural projects, specializing in the use of computation within the design development process. In addition, he is the lead VR developer for the Zaha Hadid Virtual Reality Group, AR/VR Research and Development Group within Zaha Hadid Architects. He has previously been a course tutor at the Bartlett University College London, B-Pro, Bartlett Prospective Master's Program, where his work at Research Cluster 9 focused on extended realities and augmentation in architectural design and fabrication, and is currently a course tutor at the Architectural Association, DRL Design Research Lab Master's Program. Well, Mr. Gomez, if you're ready, I would like to invite you for your speech.
Absolutely. Thank you very much for the introduction. Let me share my screen.
You're welcome.
Well, so yeah, I mean, like I stated, Manuela was supposed to give this conference. It's a shame she wasn't able to join because of some conflict of schedule with a last-minute meeting. So I'm going to take over instead. I'm going to try to give a kind of like a broad overview of the way that we see resilience, regeneration within the studio. Particularly when it has to do with innovation and our practice, which is kind of like what makes Zaha a unique place to work. So to get started, first, I'm going to give you an introduction of myself. I am, like I was stated, I'm an associate at Zaha Hadid, where I've been working over the past 10 years. I'm also a VR developer within the ZH VR group, which is a research and development group within the office. I was previously teaching at the Bartlett School of Architecture. I was co-leading a cluster that was specialized in the use of augmentation and virtual reality for fabrication and for design and anything related to architecture that had use for these technologies. And as of now, I'm a student. I'm a tutor at the AA DRL Design Research Lab program, where I'm teaching together with Patrick Schumacher the master program for the DRL. So this is some of the work that I've produced in the past related to the office. So like you can see, I mean, I've been involved in projects of pretty much any scale, from master plans, buildings, towers, metro stations. I've also been involved in projects that are a little bit more experimental, like the ones that you see on the screen right now, that are related to the way that we explore the technology in terms of virtual reality and augmented reality. And this is the work that we were producing at the Bartlett. My colleague Igor Pantic, that you see on the bottom right of the image, he is the one that developed this pavilion a few years ago in Tallinn that was built entirely using a HoloLens as the driving kind of like medium for being able to fabricate this, right? So geometries like this are very hard to describe. So being able to use augmentation for this kind of like enhances the kind of like the handcraft nature of it, but at the same time, it provides this very unique way of communicating very complex designs. And the previous years, we were exploring a little bit the ideas of what eventually became publicly known as, I guess, as the metaverse, which is the idea of a virtual city or a virtual cyberspace that is shared, that is permanent, that is online. And then what does it mean designing a city that behaves specifically in a virtual manner, right? So it would be about exploring the urbanism and exploring the kind of functions and navigation and other features that would be necessary for a system like this to work. These, at the same time, are tools that are also useful for us to develop regular master plans, where some of the constraints kind of like remain within that, within the same. So a little bit of an introduction of Zaha Hadid Architects for those of you that may not be familiar. Zaha Hadid Architects is an architectural office that is mainly based on London. It was founded by Zaha Hadid on the left in this image, and it's at the moment after she passed away in 2016, has been led by Patrick Schumacher that you see on the picture on the right. Our main office is in London, but we have also an office in Beijing that is pretty large, and we have smaller offices in Shenzhen and Hong Kong. We have projects scattered all over the world of pretty much any type. So the office itself was founded in 1979 and has been at the forefront of architecture, art, and design for the past 40-something years. It's internationally known for dynamic and innovative projects, which have to do a lot with the way that the practice has to, looks into design and research. So this is a picture of the. Right now, we're about 500 people strong. So this is a picture of most of the people in the office. And well, we have, like I said, we've had experience in pretty much any type of project, any topology and any scale, and virtually everywhere in the world. So we have from cultural projects to office and mixed-use buildings, projects related to transport and infrastructure, airports, stations, bridges, to residential and hospitality. We have a number of residences, a number of residential towers, a number of hotels. Sports, particularly lately, we've been involved in a number of stadiums in the Middle East, in China, in the UK. Civic buildings, museums, education, right? We have libraries, we have schools. Master planning, this is something that we're also doing a lot more lately, projects of very, very large scale, from large city blocks to literally entire cities, and retail as well. And among these, we also have exhibition designs and installations that are much smaller scale, where we try to explore different aspects of fabrication and design. I'm going to go a little bit deeper into this a little bit further, because this kind of like goes back into what I mean about resilience. We also have had the luck to have collaborations for wearables, for furniture with other artists, both across architecture and fashion and other industries. So the way that I want to tackle this topic of resilience is the way that we see resilience through research, innovation, and this very specific relationship that Zaha has with academia. We're deeply embedded in the Architectural Association and the Bartlett School of Architecture, particularly those two in London. And a lot of this new innovation and constant renewal of tools and knowledge comes from this relationship, where we constantly take students, teach them a lot of our R&D that we develop in the office, and then they carry on, develop it as their own projects, and then this fits back into the office when they typically join after they finish their programs. So within the office, we have a number of R&D groups, research and development groups. I'm going to go over a few of these that are kind of like key to keep this trend and of development constant in the office. They all use slightly different workflows and tools, but at the end of the day, we all kind of like end up feeding back to each other. So these are the 4 R&D groups that I'm kind of going to focus on. First one is the ZHBR group that focuses on virtual reality and augmentation for architecture. ZH Code that focuses on computational design. It essentially leads to fabrication and well, I'm going to elaborate a little bit on this a little bit later. ENS, which stands for Environment and Sustainability, which has to do with the way that we analyze our projects in terms of sustainability standards. This is something that has been growing more and more strong as of late. And Zaha AI, which stands for Analytics and Insights. I'm going to go a little bit deeper into what this group particularly does a little bit later. So I'm going to get started with Code, because it was the first one founded in the office. So Code was founded 15 years ago, and it stands for Computation and Design. And it's an internal research group that focuses on strategic innovations, and is mainly driven by the use of computation. The group explores new technologies in structurally aware geometry, robotic fabrication, industrialized construction, and others, right? So it's a very wide range of interests. The aim is developing a bespoke or a custom computational framework that allows us to incorporate innovative ways of addressing participatory and sustainable development into the daily workflows of our practice, right? So these are very, very well embedded in the way that we produce projects on a daily basis. And these prototypes that you see on the screen, right, are typically pavilion scale, like I was mentioning, is a lot smaller. Feedback into the design, fabrication, and assembly of complex geometry, and continually grow our knowledge into using these experimental projects. And then this knowledge eventually finds its way into the larger architectural projects that get developed by the office. So over the years, the research studies have gathered around 4 areas that can be broadly classified as manufacturing technologies and responsible design, modular construction and generative design, as of late, gaming technologies and participatory design, and Web3 technologies and virtual environment design. These are all powered by a custom-made parametric design tools that have been developed over the past 15 years as applied research as well, right? So these are very, very well embedded in practice. These are tools that we actually use to produce our buildings. These are not only research tools. One of the key things, like I was mentioning, that has allowed Zaha as a company to constantly regenerate itself and push the envelope is the particular relationship that we have with academia, right? Because so many of our colleagues at the office, which is, I believe it's something, it's in the tens of 20 or 30 people that are involved in academia in one way or another within the office, whether it's as tutors or as jurors, or we take advantage of strategic academic partnerships that we have. So there's a virtuous cycle between our R&D departments and universities, particularly the Architectural Association and Bartlett, where we have this feedback loop between the both of us. So our practice has always had a defining relationship with the AA, particularly since Zaha's time there. So for example, this, what you see on the screen is an investigation into customized housing that was developed in the AA in the DRL about 20 years ago by Manuel Agato, and was recently reactivated on the back of a booming co-living trend and developed by students under the tutorship of the Zaha teaching staff, particularly Shaye Bouchang, which leads the code design group. So this academic research eventually found a way into a real-life embodiment in this project, which is commissioned to Zaha by a developer in Honduras, and is developed by us together with a set of former DRL students that are now our colleagues. In this project, our client was enthusiastically invested in participatory technologies, in which user-focused design and social interactions tangibly inform the design through a configurator platform. Right, so this is a software platform that allows users to kind of like customize their own units and their own living cells. So with this, the name of the project is the Roatan Beyaboo. So this residence is an architectural and technological platform that create and curate residential developments that can prosper socially and ecologically. So turning what is typically a classic top-down design approach into a bottom-up approach. And the project tailors itself to the climate and to the terrain and allows the inhabitants to personalize their own homes, right? So they have this configurator where they're able to really make their own homes unique. So with this design of the residence, we have also adopted learnings of vernacular wisdom with timber construction and climatic appropriateness and cultural particularness. So the design hinges on the use of timber that is available locally. And alongside with AKT, our engineering partner for this project, we had adapted our design approach to materials and fabrication methods that are locally available, starting from understanding the local supply chain and logistics. So we aim at generating a library of building parts that are tailored to the design, digital design fabrication methods that are available in local manufacturing facilities, hoping that the project can also act as a catalyst for the economy of the area. So this is one of several examples of how the aesthetics of the designs kind of like goes hand in hand with the physical and the social performance. Another example that is worth highlighting is this one, which is a bridge called the Striatos, which is designed to minimize the use of concrete and was exhibited during the Venice Biennale a couple of years ago. And the project was made in partnership with the Block Research Group, the BRG, at the ETH University in Zurich, and the building manufacturer Holcim that specializes in concrete, obviously. So what makes this one unique is that the bridge is assembled out of 3D printed concrete blocks, but without any mortar, any reinforcements, or any sort of glue of any type, right? The entire thing works under compression. There's no rebar, there's nothing else. It's literally only compression working. The pieces are 3D printed, and the process of 3D printing took 84 hours only. So that roughly means that each one of these blocks that you see on the screen took about 2 hours to be 3D printed. And the goal of this exercise was to demonstrate that 3D printed concrete elements can be used directly as structural components when designed in a sort of unreinforced masonry system. So sustainability is also at the core of our R&D as well, right? So for instance, the reinterpretation in this particular project and in this one that you see on the screen of traditional masonry techniques allow us to expand on the beauty of the Baroque stone walls whilst capturing the inherent economy of these means, right? Using the natural materials and consequent low carbon footprint. So like stated before, eventually these experiments that are produced in smaller scales and kind of like pavilion-like structures make their way into the design of the larger architectural projects. So this is an example of such. So these bolted stone shells were designed for a metro line in Dnipro in Ukraine, and are an example of the application of this kind of like line of research used in an actual architectural scale project, where the self-supporting property of the traditional stone bolt is stretched to the limit and structurally enhanced by means of localized steel enforcement. So another area of research and development within the office that has been particularly pushed over the past few years is the sustainability team. So we have now a team of specialists within the office that is looking specifically into these topics and supporting teams from very, very early stages all the way to the delivery of the projects. We take as a basis that the UN 2030 Agenda for Sustainable Development was adopted by all member states from 2015, establishes strategies that improve health and education, reduce inequality and spur economic growth, as well as tackling climate change. So as we have identified a few projects that we have, which have the opportunity of becoming an example in this sense, where the 3 pillars of sustainability, social, economic, and environmental, are woven into the fabric of architecture and its activities. So with this in mind, the office has established a specialist group, like I was mentioning, that has developed tools that are aimed at the dissemination of low carbon knowledge throughout the office at all levels. So we monitor carefully the carbon levels of all our project designs, built and unbuilt, and we always try to target certifications when we're producing these buildings, and we usually target gold or higher. So because our work is kind of like spread around the world, there's a variety of cultures, of clients, and of regulatory systems. So ensuring consistency between the low carbon output for the projects is very complicated, right? Because the standards for what a highly efficient project in China mean are very different from what they mean in UK, right? So you have to comply to certain sort of specifics. So what we try to do is that we analyze future and past projects, and we use a baseline. So we compare it to a project that we have established as if they were in the UK, that allows us to have a consistent benchmark so that we can compare apples and apples between all the projects, and we're able to find successful strategies and implement them in future projects, right? So that we constantly keep an eye on sustainability within all the projects that we have been developing over the past few years. So like I said, this has received a strong push over the last few years. We realized this is priority for everyone, and this is something that has to be addressed from the very, very beginning on the design stages, and then carried on all the way through the later stages of the design. So we have an in-house support team for every project at every stage, from initial ideation processes that help us inform the design before decisions are made that can have potential detrimental effects towards the future. So some of the considerations that we have are the climate impact on public health and safety and on the economy. We know that the ability of dated infrastructure systems to withstand things like flooding, like fires, like storm, abnormal temperatures is fading, and it needs to be addressed. We know concrete is one of the construction materials with the greatest environmental footprint. So we try to encourage the integration of carbon neutral concrete and recycled construction materials for aggregates. We see rebuilding, considering energy efficiency and adaptation to climate change as design opportunities. Renewables will be crucial to the end of the fossil fuel dependency, and these are quickly becoming an integral part of architectural design. There is no longer the need to compromise when one needs to use renewables. And a lot more can be done, and we see a number of opportunities in the following sustainable design principles, including rethinking some of the ways that we've been doing things up to now. right? So for example, the project on the screen is a flood defense, doesn't necessarily need to be a barrier, right? So there is the opportunity of integrating public spaces within this. On other further strategies, things like considering relocation of buildings under serious flooding risk, updating building codes so that the new construction is built to fortified standards, elevate houses and buildings as design strategy as a preventative measure against flooding. Utilize impermeable pavement. This is a kind of like a big one. We're also aware that to meet the 2030 challenge, we need to not only achieve net zero operational carbon, but we also need to drastically reduce embodied carbon, right? So this means having a look at the materials, at the way that we're designing very, very early stages, not only the way that the building operates after it has been built. We choose materials very carefully, and we do as much as possible to reuse rather than demolish. We also consider very important the implementation of sponge city strategies, right? So as an example, the project that you see on the screen is so transport hubs can double up as public spaces and improve the permeability and manage stormwaters, right? So runoff of stormwater continues to be a major cause of water pollution in urban areas. It carries trash, bacteria, and other pollutants that can storm sewers into local waterways. So these strategies can be implemented from design stage, right? And have a very big impact towards the lifetime of the building. We also target designing energy efficient buildings using passive climatization strategies that aim at ending fossil fuel dependency without compromising the design. So as long as these are designed in early stages and considered in early stages, there doesn't need to be a sacrifice in achieving a good architectural design with being able to accomplish all these principles. And then there are all a number of ways of integrating urban renewable energies, right? From solar energy on roofs and facades, photovoltaic glazing for windows, ground heat pump systems under the building, throughout photovoltaic power generation, efficient water management system, displacement ventilation and below ground, and thermal labyrinths, innovative natural and cross ventilation solutions, among many, many others. So another example of a project where we try to exemplify this is attempted to implement as much of these strategies as possible is this one. This is the Forest Green Eco Park Stadium. It's a 5,000 seat, expandable to 10,000 feet football stadium planned in the UK, for which we use timber as the natural material with very low carbon content, high durability and recyclability, attempting to become the lowest carbon football stadium in the world. Some of the largest carbon footprint that football in general has to do with the way that the stadiums are built. So being able to address this from the very early stages has a big impact towards the future. Another research group that we have in the office is Sage AI, which stands for Analytics and Insight. This is a group that has been working in the office for the past, I believe, 6 or 7 years. It uses AI, among other algorithms, to kind of like help us facilitate design and analysis for designs. So the work encompasses tools that can be used both for furniture and office layout, and also for designing master plans, right? So master planning. It's part of a technical team that supports all of our colleagues with insights during the design process, mainly giving feedback on producing quantitative analysis about design options, right? So we're able to measure what the implications of our decisions are from very early stages. Roughly to explain a little bit where they come from, in the 70s, MIT professor Thomas Allen discovered that communication and collaboration increases exponentially with proximity, and that the opposite is true, right? That it decreases drastically with distance, right? That it doesn't follow a linear distribution. So based on this, the proximity that you have to your colleagues in your working space makes a big difference. So in this case, in the case of an office space, co-workers that are more than 24 meters away from you might as well be in a different building. So this concept is known as the Allen curve, and it follows more or less the description of the curve that you see on the screen. So based on this, the team has developed a number of tools for sampling and analyzing this relationship for each of the design workspaces in a procedural manner, right? So we're able to take every design building, early stages, run this analysis, and be able to visualize what the implications of certain layouts are. We're able to have a look in a very graphical and intuitive manner like this, what the average distance for each work to be studied in a very intuitive manner. This is very hard to understand as you're preparing layouts yourself, but once you see the way that the space gets colored, then you get an intuition of what is happening, and you're able to design around it. So in this particular example, for example, most desks display a productive degree of communication, but the corners of this plate are 30% less communicative, which means it doesn't mean that they are bad. It just means that they are more suitable to a different type of program, right? So we typically design spaces in that manner. We find areas that are more isolated, and we implement a different type of social space in there, for example, or meeting rooms, or there's usually a way of addressing this. And likewise, we're able to study an effective distribution of meeting spaces using similar strategies. So provided the data, we need to prove to we're able to provide data to prove to our clients that the layouts are balancing meeting rooms and that everything is evenly distributed. We also use similar strategies to study how people connect within the office by mapping the social networks onto the space. So research showed that sitting next to the right people tends to have the greatest impact on your job performance than anything else in the built environment, as they typically amount to 40 to 60% of all the daily interactions that we have, including digitally. So hence, being able to efficiently allocate common relationships is key at early stages. This is obviously something that is developed together with clients as we are producing the brief, but this is something that we try to take a look from very, very early stages. And likewise, being able to determine how many desks are within your field of view is another useful metric that provides insights into how efficient we can have a workspace, right? We try typically to encourage open plans as much as possible, and these are things that are very suitable for this. Other key parameters of an office plan are light penetration, visibility, and views. So here you see an algorithm looking into the possible solutions for building core positions on a tower plate. And we don't just find out which is the best option based on parameters, but also which is the best option when we have specific targets. And because we have these tools that are very fast at running a lot of iterations, we're able to run hundreds of thousands of tests within a day and select the ones that are most suitable under very specific circumstances. This is also about priorities, right? So there is no project whose parameters of success are the same. All have different environments, the client has different ambitions, we have different views. So all of these values are weighted differently depending on the project. But we're able to analyze a lot of them and then come up with a set of solutions that are typically useful. So as we're developing the design shapes, we're also able to quickly analyze what the implications of what a good or a bad design in terms of office layout can be. And this is all happening in parallel. And these criteria can also be incorporated over the lifespan of the building. That this doesn't need to be happening before the design and then after the building is constructed, that's it. It can be built in a live manner by constantly updating through sensing and through the use of digital twins. This is an example of a project we recently completed where we used a lot of these strategies. This is our Infinitus headquarters in Guangzhou, in China, where by simulating how people move through the space, we found that organization systems are more flexible and adaptable than others. So here you can see the heat map, like natural daylight, distance to entrances, visibility, and other parameters are able to influence the distribution and the placement of the work setting, and how this can be further developed over time. We also want to be able to adapt the design based on people's preferences and adapt the space as the building goes through its lifespan. So this capability needs to be designed and it needs to be embedded in the building. And this translates into carefully balanced ecosystems of different work settings, which make for successful workplaces that have the ability to easily change and adapt to changing circumstances. So these space planning algorithms also have been developed a little bit further to assist in the design of larger scale projects. The one that you see on the screen is the Unicorn Island in China. It's a very, very large master plan. It's a couple of million square meters. And similar tools can be also used to inform the design in a similar manner. See, some of these kind of like follow similar criteria. So we start, for example, by defining a possible distribution of options of the building mass on a given site based on a design that has been prepared at the concept stage. And then the computer automatically generates building outlines for a number of options. With this, 1,000 options are evaluated and generated, studying light penetration and visibility. the performance of each one of them can be mapped in a coordinated system so that it's much more intuitive to see. In this case, we see the poor performance floor plates shown in the lower left and the high performance shown on the upper right. So this gives the design team an intuitive way of understanding and the design decisions, right? So every time you make a change, you can see what's happened, where the efficiency of the project essentially went. And this allows us to select options that we know have a certain degree of success. So these are some of the top performance found by the algorithm, follow the initial design idea. So these options have a larger floor plate that is offering great visibility across the floor plate as well. At the moment, this entire project is under construction, and these tools and algorithms help us evaluate and make informed decisions based on the options we end up with. So it certainly is not taking away the job of the designer, but it helps us make a more exciting and efficient job, right? So this is roughly the way that we've been using this technology as of now. The next the research group that I'm going to focus on is the ZHBR group. This is a group I'm a member of. This was our BR space before the pandemic. So we established the group in 2014 when we got our hands on some of the initial prototypes for the headsets, essentially the Oculus DK2, I think it was at the time, or the DK1. We found the potential in the technology, and we decided to start implementing it within the office. So the question is, why VR? And I think by now, if any of you have tested virtual reality as a technology, you may know what the answer of this is, right? So we architects are typically very well equipped to take a two-dimensional representation, a plan or a section, and we're able to imagine the space behind it because that's our training, right? That's what we have been doing for so many years. That's what we did in academia, and that's what we have been doing in our professional lives. So we're able to understand this, but clients have a little bit of a harder time doing that translation. So the usual is that we also produce a render, right? A three-dimensional representation, an image of this. So for example, the project that you see on the screen, the render on the left was produced originally to sell the project, and then on the right, you see the photograph, right? So there's a closer and a more literal translation between the actual thing and the representation. When there is budget and there is time, we also will try to procure a film or something that allows us to convey not only the three-dimensionality, but also a little bit time, materiality, what it feels to actually be on the space. But all of these mediums are still imperfect ways of communicating 3D space because they are communicated in the two-dimensional screen. So that's where VR comes in, right? So VR is a very useful tool for communicating space. So with this in mind, we started kind of like playing the technology with the technology, and now it's almost a decade ago. And the way that we were able to seamlessly kind of like integrate this in our typical workflow was, first of all, using 360 images. These are very easy to kind of like embed in any architectural workflow because we typically produce renders as a standard. So producing a 360 image is not really a lot of additional work. So this is the first thing that kind of like got stuck in the studio. We were starting to get used to have client presentations where we would travel with a number of headsets. We would essentially prepare our own, develop our own app, and a bunch of these would be thrown on the table, and then the client would be able to essentially just grab the headset, put it on, and have a look at the design options. One of the disadvantages of doing this is that only the client is able to see what they are seeing, right? You have no idea what they're looking at behind the headset. So we had to develop a number of apps that allow us to bypass that problem. So we have first the simplest case, which is just there is a device with a looping set of slideshows, and you know that the client doesn't have any control. They are only looking at the images in a predefined loop. But if we're going to give them a little bit more control to be able to navigate and choose the spaces they want to go to, we need to be able to see what they are doing. So we developed this application ourselves that essentially we had the headsets, we put it on the table, and then we would have a tablet where we would see what they were looking at. So we would be able to more or less direct the experience. We would be able to tell them, hey, don't look at this, or maybe I need to take you to this space. And we would be able to more or less direct the experience that the client was having. But this is a very simple way of using VR. It's not particularly exciting for any of you that may have used it because the point of view is not actually moving, right? You are just embedded in a screen, sorry, in a sphere that has a fixed point. The real potential of VR is when you have the ability to navigate the space. And this is needed, for this, you typically needed kind of like a very beefy hardware. You need a strong machine, and you need what back then was an expensive headset. So this was the first attempt that we did at using the technology. These controllers were actually the development kit for the HTC Vive 9 years ago. And we started to see what can we do that you can't do using anything else, right? And this was the first thing that we came up with, which is what happens if you treat it as a physical model, right? Like you can scale it, you can rotate it, you can analyze the sun, you can stick your head inside. This is a very trippy feeling. And what the potential of doing this, right? So this essentially kind of like was a bit of a eureka moment for us, because this is something that you just can't do in any other way. And then immediately you can transition to a more traditional way of, let's say, perceiving the building, where you go to a full scale, where you have full quality for the visuals, and you can go with the weather and materiality and everything else. So once we had more or less established that there was a potential for this, we founded the group, and we started finding a few opportunities for the technology that go beyond just the representation of architecture. This one is kind of like going along those lines, but this is a collaboration that we did with Epic Games back in, I believe it was 2018. Epic Games are the developers of Unreal Engine. This is a software that is used for making video games that we use for producing these virtual reality experiences, where we discussed about the potential of just taking one of our most iconic buildings. This is the Hadid Aliyev Center in Baku, Azerbaijan. And we turn it into an experience where you can essentially kind of like walk around the entire space using a mouse and a keyboard, right? This was essentially traveling around exhibitions together with the Epic team. And it allowed you not only to get some very high quality visuals when it comes to kind of like outputting an animation, but it also allowed you to essentially go through the entire space, right? So a lot of us are not going to have the opportunity to go and visit the building itself, but this is a pretty good second base because it allows you to really explore the interiors and get a feeling of what the space is. This took us about 2 weeks to develop. So the process of actually developing the model is not an easy one. It's not a straightforward. It's not just a simple import. There is a little bit of process that needs to be done, but it definitely pays off, right? So there's a little bit more pain than traditional renders and animations take. But the fact that you're able to do something that is fully navigatable, it's a really, really big plus. And the visuals that you're able to get out of it are pretty stunning, in my opinion. This is pretty close to what would have been unthinkable 10 years ago. Another kind of like area of research using the technology as well is using this as the art medium itself. So when Zaha passed away in 2016, for those of you that are not familiar, she gained original notoriety because she was using paintings to communicate her designs, right? So these paintings would typically be about a specific project and would be communicating the different perspectives in the project. Now, obviously, the paintings themselves had a lot of value, but they were intended to communicate actual projects. So when she passed away, we had the opportunity to exhibit some of her paintings in the Serpentine Gallery in London. And we took the opportunity to take a few of her paintings and kind of like break down what the original concept and geometry that was meant to be communicated behind them was, right? So this experience was would take essentially the painting that was actually communicating a three-dimensional geometry, and it would break down and take shape around you. So you would more or less get an understanding of what the original idea of what was communicating, of the 3D geometry that was being communicated in this painting was. So this was kind of like a very interesting opportunity to explore AR as the end goal rather than as a representative medium. Another opportunity to kind of like explore participatory design was this exhibition that we did in Mexico City. So the experience was about having kind of like a very large open space and then give users some sort of a basic ability to generate designs and space with a very simple set of design kind of like interactions, right? So most of the people that would be using this would be first timers using the technology. So they allow this essentially meant that we had four stations next to each other. User would be given kind of like a quick tutorial of how to navigate, how to use their body, how to use the controllers, how to move through space. This was a very large space. It was 8 kilometers by 8 kilometers. They would be given a series of these small components to create aggregations by themselves, complete freedom as what the size of these components could be, orientation, whatever people wanted to assemble, they could do so. So some people would collaborate with each other. Some people would just go into the middle of nowhere and do something very random. And they were giving some sort of tutorials for being able to navigate in what we thought was a very simple and kind of like intuitive fashion. Then they would be dropped into this gigantic 8 kilometer by 8 kilometer space, and then people would just go on and create together in collaboration, right? So some people would, like I said, go together, build something together. Some people would go on their own. Some people would be actually very disruptive of what other people would be creating. But for us was an interesting example of seeing what people would do when they were dropped into kind of like collaborative environment. So you see a couple of people there kind of like creating these little things together. And then after a number of weeks, what we did is that we took a snapshot and we 3D printed it. So this is the result of the entire course of the exhibition. The exhibition was running for 3 months. So this is what happened over the course of the 3 months. We were able to kind of like consistent, this was persistent. So as some users would arrive and build, they would be building on the work of other users that had been in the space for the previous time of the running exhibition. So at the end of the day, it was, I believe, something like 1,800 components that were dropped by, or 1,800 users, and that ended up dropping something like 12,000 components, right? So it was growing at a very, very fast pace. A lot of this was very random, but we were able to, halfway through the exhibition, take a snapshot of a small section of it, and it became part of the art that was in the exhibition. Another way of using the technology is actually using it for design. Right, so we found that there are certain opportunities where designing virtual reality is actually very convenient. If there's a particular scale where it works very well. When it comes to furniture scale, to relatively small objects, it works really well. When you go to larger scales, it's a little bit harder to control. But we've found success in some of these. So, for example, this is a piece of furniture. It's a 12-round speaker system, kind of like very high-end cinematic system. So behind this, you would have this super high quality speakers and sound system. And this was initially designed and sketched using VR as a medium, because it worked very well when it comes to figuring out ergonomics, and at this scale is really easy to control. And because it's all developed in virtual reality, we also have all of this in a virtual reality model, in a real-time model that allows us to also extract all these visuals and all these animations essentially for free, right? At any point of this, I can stop and move the camera and change materials and do whatever I want on a live fashion, which is a very powerful tool when it comes to exploring design, right? Being able to have this fidelity on a real time. And I'm going to finalize with this project that we've been doing also within this group. This is something that has been running now over the past couple of months. It's a quote-unquote metaverse platform. It's a virtual city where we're hosting different designers within this kind of like virtual exhibition. And this is going to be running on from now on. The idea is that this space is just going to be growing, where we're hosting events, and we're hosting lectures by artists, by architects. And you're also able to walk around the work of these architects in this kind of like virtual platform that is designed to be native. So you have a little bit of an avatar, and then you're able to walk around and navigate this space freely. This is all accessed online. At the moment, it's accessed on an event-based. For example, it was open for the Venice Biennale, and it will be open for the Chicago Biennale the following month. So this is the way that kind of like putting this together and the way that these assemblages are happening. So we have at the moment a number of exhibitions from very renowned architects. We have MAD, we have Coop Himmelblau. Let's see, we have Morphosis, we have UN Studio, we have Zaha, we have a number of artists that have been kind enough to lend us their work to live in this platform, and people are able to kind of like go in and navigate, experience these 3D models and these works in a very unique fashion. Almost literally, like I was showing before, you can stick your head into each one of these buildings, and then you can see in a much closer view than the typical renders that circulate online what the design notations are. So we find this medium to be a very powerful way of communicating the work that we typically artists and architects do. And this is a platform that communicates the work from a lot of artists throughout the world. So this is something that we're very proud to be developing with a number of artists. And Yeah, so you can follow up this. This is called the Metrotopia platform. You can go to the website and see what the events are. You can essentially book yourself a space and visit it if you want to do so. The exhibition is going to be running at some point on a permanent basis, not only on an event basis, but this is kind of like where the start is. And finally, just to complete, this is kind of like an overview on the way that we actually produce buildings at Zaha and our designs, and how we kind of like take the work that I was talking all about before, this work that has been developed by research groups, and how it actually applies in some of these architectural, more practical projects. So this is a project, for example, for a hotel that we did in China. I'm going to talk specifically about the very large building in the back to explain kind of like the processes and the way that all these procedural and generative methods eventually make their way into practice. So for example, this entire building was actually defined by these curves that you see on the screen. Nothing else is manually modeled. Everything else is just built on parametrically. So we have this gigantic Grasshopper script that takes these curves, take a section of it, produces the geometry that is used for rendering and for visualizing it. And then another part of it produces the metadata that we use for producing drawings. By metadata, I mean, for example, each one of these points represents a door and the direction at which this door opens. Each one of these lines represents a wall. And what we do is that we take this geometry, this metadata, into Revit, and then Revit builds everything that has to do with the building information, right? So we're able to, at the same time as we're designing, we're producing the BIM model. These are tools that we built in-house. This one specifically was built by a German guy called Eckhard Schwarzfeger, which was just absolutely brilliant using the Revit API. So what we would do is just produce this data, press a button, go get a coffee, come back 15 minutes later, and the drawings and all the 3D data would be essentially processed. It would take about 10 minutes to import all this information. And it would go all the way from creating native Revit elements for curtain walls, for doors, all the way to furniture, to circulation, and so on, right? So we typically try to use this research that is produced for these more experimental projects and actually use it to make our lives a little bit easier when it comes to designing. Similar tools are used for master planning, where we use road networks to analyze, generate city dressing, generate the plots that eventually become the buildings, and so on and so forth. And that allows us also to get to a very crazy level of detail when it comes to our presentations, since we're able to quite easily and quickly extract all this data out of this information. So these are all in-house renders, for example, that we produce for presentations for our clients. These are not the ones that we outsource that are much higher quality, but we're able to populate the entire city. And because it's all built procedurally, this happens with a very cheap fashion. At the same time, it allows us to take master plans like this and model every facade, right, to a degree of very high degree of detail, right? Every facade is designed as a set of families for what is a residential facade versus what is an office facade, and so on. And all of this is built in a kind of like procedural fashion. And this is the final project. So this is a bank that we did in Moscow. And this one shows kind of like the entire process. So like the previous project, this is described by a very small set of curves that generate the facade. We use those curves then to generate this metadata that describes the panels. So all the glazing panels, for example, are described by 6 curves that are eventually turned into double curve or single curve or flat panels when imported into Revit. This allows us to quantify what is single curve, what is double curve, what is flat, which is essentially where most of the cost of the facade of the building goes to. We're able to optimize and reduce these numbers and maintain the design idea because we're able to measure and quantify all of this and quickly translate it between one software and the other. We're able to use the same information to produce a structure. And at the same time, we're able to produce a virtual reality experience that can be shown to the client, where the client gets typically the way that these projects kind of work is that you have one meeting with the person that makes the decisions for how the project moves forward every 6 months or so, right? So you want that meeting to be really meaningful. You want him to really be able to make the decisions that need to be made, because it's very hard to get hold of him. So these experiences have proven really useful at quickly showing design options that we typically present with different rendered options. And this allows the client to immediately get an idea of what the differences are and immediately say, okay, I actually want option A. I didn't fully understand it in the images, but it's a lot clearer when you see it live. And we're also able to communicate the design, in all the weather conditions that you have in reality. So here, for example, it's snowing, because why not? So we're able to elaborate a lot on the way that we present our tools. This project was also used, developed in the same way, using the tools for space planning that I presented before. So all of these research groups kind of like focus and converge into the way that we end up developing all of these projects. So yeah, I mean, this is all I have for you. Hopefully it wasn't all over the place. This is my information if you want to reach out or if you have any questions. And I'm just going to leave this video running. And if you have any questions, please feel free to let me know.
Mr. Gomez, thank you so much for your inspiring and informative presentation. We already have 2 questions now, but we have a limited time. Our parallel sessions will be starting at 11 a.m. So I'll immediately let you know about the questions. First question is from Selin Oktan. Thank you for the inspiring presentation. You construct your buildings in various cities with a high need of digital fabrication tools. How do you manage to fabricate the parts of the buildings? Are they fabricated on site or transport them from another city?
So it depends. For the most of it, we try to find local sources of materials, right? This goes again into this topic that I was talking before about the carbon footprint, right? So there's an embedded carbon. If you have to fabricate and then transport, there's an additional carbon footprint that gets emitted there. We tried for the most of it to find local suppliers. Most of our work is in the Middle East and China and Europe, and it is relatively easy to find suppliers for all of these within each one of these countries. So for the most of it, we have already a set of, let's say, fabricators that we are trusted, of engineers that we're able to work with locally, that are able to also specify for the specific places. So a lot of this happens just over the number of years that we've been working in these places. We already have a network that allows us to actually go on and fabricate this with a certain degree of confidence. But yes, it is key that this is fabricated as close to site as possible to minimize carbon footprint, among many other logistical complications.
Thank you. Another question from Tanya Urso-Martso. Thank you for sharing the work of your office. Do you find that sometimes computation fails? What I mean is that it fails in terms of simulating the actual humanistic experience once the project is constructed and physically occupied.
Yeah, well, I don't know if fail is the word. You are never going to be able to predict how humans behave within a space, right? The best thing you can do is do an estimate and then hope that it gets you a little bit closer than not having anything. So a lot of these tools provide us, like, I mean, it's almost in the name, right? Analytics and insights. It gives us insights. It doesn't tell us exactly what's going to happen, but it's a more informed decision that you take if you don't have any of these tools. I wouldn't say that computation fails, but it can be validated after the fact, right? So you can run an analysis before you build, and then run the analysis after the occupation of building through sensing, like I was mentioning before, and then compare the both of us and see what the discrepancies are. Within our office, I mean, literally our physical office, we have some of these strategies as well, right? So this is first tested in our place. We kind of like validate some of these assumptions, and then we implement it in the broader options. But it's never going to be totally precise. Different cultures have different ways of behaving. What we try to do is just do an estimate that is better than not having anything.
Thank you again. Well, you have a reply from Selin Oktan. She says that if you need one in Trabzon, we as Karadeniz Technical University Department of Architecture can help you, she said.
That sounds great. Absolutely. Just find me a project, please. We're always happy to work anywhere.
Okay. Another question from Çağlar Aydın. Thank you for the excellent presentation. Do you think current softwares you're using holding back from you what you would like to achieve? What can be improved that can open new horizons for you?
It's hard to tell, right? So whatever you produce is shaped by the softwares you use, by the tools you use, right? Whatever work we're producing right now is going to be different in the next 10 years because we're going to have different tools. The way that the office works has actually been quite shaped by the softwares we use. We typically work very intensely with Maya, which is usually an animation software, polygonal modeling. So a lot of our buildings have this very embedded aesthetic of what Maya looks like. At the same time, we try to break away from that by looking into coding and customizing our own tools, adding functions that the software doesn't actually have, so we're able to expand on it. I don't think the software necessarily holds you back, but it does shape in a way the way that you work, right? There's no escaping that. But what Zaha does very well is because we're deeply embedded in academia, meaning we have a master's program from which we get students. As soon as there is a new tool that kind of like breaks the box, right, that is starting to show that has potential to produce something new, we're able to quickly embed it in the practice, right? Because then we're able to hire these people, let them play around with their ideas, that eventually becomes something for the office. And then it starts again this virtuous cycle where we take that back into academia, explore with it, take it back into the office, and then so on and so forth. AI is the obvious one at the moment, right? We're gonna have to figure out how we actually use AI for designing within the office. But these are all kind of like, yeah, I mean, these are things that are happening, right? It's not the same when you were producing a building by drawing it every last detail 500 years ago versus what's happening right now. We're just shaped by the tools we use.
Thank you again. I guess we don't have more questions. So I am ending this session. Mr. Gomez, thank you so much again for your presentation and your answers. Now we will take a break for the Congress, and our program will continue with the parallel sessions at 11 a.m. See you all there, and I am wishing you all a good day. Thank you so much again for all attendees, everyone contributing.
Thank you, everyone.